Hello and welcome to part 2 of lesson number 5 in Unit 6, Solving Problems with Quadratics in our grade 10 academic math class. So we just worked through a question that was a revenue question where we weren't being asked to find an optimal value, we've been asked to solve it. We ended up with two viable solutions, which is new for us. We're going to look at a variation on the border style problems that we've been looking, or that we had been looking at. This one has the variation where we're only taking, or in this case taking, but could have been adding an amount to both sides as opposed to all four sides. So let's read through the question. An L-shaped garden is to be made inside a rectangular yard by digging out a strip of the same width along the left side of the yard and the bottom of the yard. If the dimensions of the yard are 31 meters by 24 meters, find the new dimensions of the grassed portion if its area is 450 meters squared. So now might be a good time to pause and sort of copy down the let statement and the drawing and sort of the setup that we've made here, and then we'll go on to solve it. Okay, so you're back. We've defined W as the width of the strip in meters. If we look down here in our drawing, we can see that we have that W articulated really nicely there. Again, it's uniform, so it'll be the same variable in both spots. The new grassed area, this section on the inside, is going to be 450 meters squared, and that's actually what we're trying to get here, is the area. So, or rather, I guess the two lengths that result in an area of 450 meters squared. So we have our area formula, length times width. We know the area, 450 meters squared, but we need the length and the width. So we're trying to figure out specifically this piece over here. We're trying to find the width here. So how do we do that? Well, the width, interestingly enough, the whole thing is going to be 24. And we are going to be taking away a W. We don't know how big it is yet, but we're going to be taking away one W. Same thing on the other side. We're looking to get this piece right here, which we'll call the length, I guess. We know that its length is going to be equal to the original 31 minus 1 W. So we now have a length and a width. Let's substitute that into our equation, as well as the 450 meters squared of the new area. So the length, we call that 31 minus a W, and the width, we call that 24 minus a W. Again, this is our, part of what makes this one a little different than the other is that this would have been 31 minus 2W, or 24 minus 2W, if we had been adding or taking away area from the outside of all four sides. This is only 2, so we end up with only 2 W's. No big deal. So now we're going to expand out and gather our like terms. So there's our 450. 31 times 24, that's going to give us 744. And we are going to subtract 31 W's. We are going to subtract 24 W's. And we are going to add W squared. So let's gather together those like terms, and I'm going to transpose 450 over to the other side by subtracting 450 from both sides. So that's going to give us 0 equal to W squared minus 55W, and then we have 744 minus 450. That's going to give us 294. So plus 294. So there's no obvious factoring we can do. Our A value is already 1. Should we be solving this using the quadratic formula, or should we be trying to factor it? Let's do the discriminant this time, since we have a little bit extra time here. So our discriminant will be equal to our B value, negative 55 squared, minus 4 times A times C. I think that was C. Yep. All right, let's put this through the calculator and see what we get. So we have negative 55 squared minus 4 times 1 times 294 equals 1,849. So is this a perfect square? It's hard to tell. I'm not really sure. So if I put this into my calculator, I realize that it is a perfect square. You can square root this. That's actually going to be equal to 43 squared. But if this is a little bit too extreme, if you don't necessarily want to try to figure out how to factor this thing that multiplies to 294 and adds to negative 55, then we can always just go ahead and use the quadratic formula. So that's actually what we're going to do today. We're going to do just our quadratic formula. So we have minus b plus or minus the square root of b squared minus 4 times a times c all over 2a's. Now what's nice about finding the discriminant is that we already know what happens under the radical sign. That's going to be the square root of 1849, which actually comes out to be 43. And that's going to be over 2. So we now have two possible solutions here. One where we have x is equal to 55 plus 43 all over 2. And the second example that gives us x equals 55 minus 43 all over 2. So let's work these out. Again, I want to finish that numerator before I do anything in my denominator. So 55 plus 43 equals, gives me 98, divided by 2 gives me 49. And in our second example, we have 55 minus 43 equals, gives me 12, divided by 2 obviously gives me 6. X equals 6. So let's have a look critically at these two values and let's see if we can make them work. So our first answer of 49, we're being asked to take this value, this W, away from 24 and 31. So we can't actually do that because if you take 49 from 24, you will have, or 31, you'll have negative numbers there. So this is actually inadmissible as far as we go. Can't use this. No good. Got to write down inadmissible there. Oops, should spell it right too. Inadmissible, which means that our correct value is going to be 6. So we need to substitute in and figure out what those two side lengths are going to be, since the question was asking us what are the dimensions of the grassed portion if its area is 450. So we need to do some subbing in. I'm going to change up my color here. So we are going to find out, so we're going to call this length. So the length will be equal to 31 minus 6, and the, and I guess that gives us 25. Should make those equals again, not just colons. Get out of there. Okay, so we're going to have the length is equal to 31 minus 6, or 25 meters, and our width will be equal to 24 minus 6, which is going to give us 18 meters. We'll do a quick check. So we'll do 25 times 18, and that's going to give us our 450 meters squared. And now we pop a little therefore statement on here. Therefore, the dimensions are 25 meters and 18 meters. And there we go. So that is a variation on the border style question that we had seen in the last lesson. This is our last example from the lesson. You have some homework coming up. Now this last lesson after this one, lesson number 6, is also sort of a doozy. So make sure you have this solving quadratics with factoring and the quadratic formula under control. Make sure you have solving problems requiring optimization under control before you head on to lesson number 6. So good luck with the homework, and we'll see you there.